Hello everyone, we are the Yunlin County Car Accident Severity Prediction Model and Hotspot Analysis. Our advisor is Professor Yang Dali. Here are our group members. On the right is the website of this special feature. It will be used in a later introduction. Today we will first introduce the motivation and purpose of the research, then introduce how to process data. Next is the training of the methods and models we use, and how to use the PR curve to select thresholds. Then look at the results and demo. Finally, we will talk about limitations and next steps. This is our motivation for research. Traffic accidents are a significant public safety concern worldwide. Taiwan's annual casualties and property damage due to traffic accidents are considerable. With the increase in the number of people and vehicles, the risk of traffic accidents is also gradually increasing. Therefore, through the analysis of traffic accident data, predict the severity of its occurrence. It is of great significance for improving traffic safety and improving accident response efficiency. Our study has 3 objectives. Goal 1 is to predict the severity of accidents. Predict the severity in real time after the incident scenario is entered. Output the percentage of A1 and A2 and the final verdict. Assist in making faster disposal decisions in the field. Goal 2. Find out the main cause of severity. Through feature engineering and model interpretation, identify the main factors that influence severity. For example, time period, speed limit, road conditions, location, and causative keywords. Provide actionable clues for improvement. Goal 3. Assist the government in improving traffic safety. Turn the results into usable tools. Includes historical hotspot maps and online forecast pages, so that police and fire units can directly use it in their daily work. Further support traffic safety governance. Here is an overview of our information. The total number of transactions was 26,678, of which only 320 were A1, accounting for 1.1%. A2 is 26,358, accounting for 98.9%. It can be seen that A1 is very small and belongs to a highly unbalanced dataset. The data period is 2024, covering all townships in Yunlin County. The definitions of A1 and A2 are based on the standards of the Ministry of Transportation, and we only use valid samples after cleaning. Then there is the low A1 ratio. In subsequent model training, we will use class weights to make the model pay more attention to A1. At the same time, the PR curve, also known as the precision recall curve, is used to select the decision threshold. Make sure A1's early warning is accurate enough. The table on the right organizes the fields. Above are the numeric fields for time and coordinates. In the middle are the category fields for environment and road. Below is the text field for the accident description. In a moment, we'll show how we can turn them into features that the model can use. We divide it into 4 steps to pre-process the data. 1. Convert the date and time into time characteristics, and mark peaks and weekends. This is to provide time period and daily travel information to the model. 2. Unify the latitude and longitude to the 5th decimal place as a value. Then use the 3rd decimal place to form a 100-meter grid. Balance fine points and adjacent blocks. 3. Turn the text of the road condition into ordinal numbers from 1 to 5 to facilitate model learning. 4. Missing value and type cleanup. We compensate for the missing numerical features with the number of bits in the training set. Ensure that the field types are uniform, to improve stability and reproducibility. Then there is the feature engineering we do. The first point is to turn the causative word into 100 numbers. Let the model know which words are the most critical. The weight of common words is low, and the weight of keywords is high. The second point is to classify similar situations such as hours, months, weekdays and holidays, speed limits, road conditions, and approximate locations into the same category. Make it easier for models to catch common patterns. The third point is to turn the coordinates into points plus blocks, both depending on the exact position. It also makes nearby locations perceive as a group, improving stability. Combining these 3 points allows the model to understand both semantics and scenes and locations. Then there are models and features. The model we use is CatBoost. This model was chosen because it is suitable for numeric plus category and a small amount of text. It was just what we needed. The usage is to enter 3 characteristics, numeric, text, and category. Then feed the model with all 3 features. It can output the percentage of A1 and A2 and the final judgment. Training and judgment. Let's first divide the data into 3 types. training, validation, and testing. All transformations are created only in the training set. Verification and testing are applied only to avoid leaks. Then use the model to train. Because A1 is rare, we have increased the training weight of A1. Make the model more concerned about serious accidents. When making a decision, we choose a probability threshold in the validation set. The principle is to prioritize the accuracy of A1 and then take into account the overall performance. Finally, look at the confusion matrix and indicators in the test set. When going online, the converter, model, and threshold are put online. Ensure consistent results. Key results. This is the result of the test set. On the left is the confusion matrix. A1 is 40 correct, and A2 is 12. Only 3 A2 transactions were falsely reported as A1. Then there are the 3 numbers on the right, the first one, with an overall accuracy rate of 99.7%. We take a conservative approach to A1. The accuracy of A1 is 93%, which means that most of the A1 alarms are correct. At the same time, A1 recall 77%, and it can still catch the majority even with a small number of A1 samples. This trade-off comes from the threshold we choose in the validation set using the PR curve. The purpose is to keep the A1 alarm from ringing. Training process. This page summarizes our process with a 9-square grid. First, load the data, cut the data into training, validation, testing, and then pre-processing. Then organize the fields into 3 characteristics: value, category, and text. Use these features to train the model. Because A1 is small, we also increase the training weight of A1. Then use the validation set to select a threshold with the PR curve. The principle is to prioritize the accuracy of A1. Then test the set evaluation once to confirm the confusion matrix and indicators. Finally, the converter, model, and threshold are encapsulated together. After deployment, A1, A2, and final judgment can be output. Website introduction and operation. These are the 2 websites we do. One is a hotspot map, and the second is accident severity prediction. Let's take a look at the accident classification map first. We only do Yunlin County. So here the map only shows the accident classification of Yunlin County. In the upper right corner, there is the accident category, time period, and year. There is a legend in the lower right corner. A1 is red and A2 is orange. For example, we choose A1, select the time, and then select the year. You will find that there are only these few strokes. Let's use this one from Hue Town. Here are the year, month, date, time period, accident category, etc. The same can also be replaced with A2. The same is Hue Town. Let's pick any one. There are also years, months, dates, times, periods, etc. Then there is the severity prediction of A1 and A2 car accidents in Yunlin. On the left, we can see that we can enter basic values, coordinates, and time. For example, here you can select the date, accident time, speed limit, longitude, latitude, and road conditions. You can choose the location here. Select the type of road here. Choose traffic signals, weather, potholes, and traffic dividers here. Lighting, obstacles, accident types, road types, shelter, and accident types. Let's take a random example, and you can also customize the input here. We use tiger tails. We can choose one at will, like Bade Road. The paving is generally asphalted. Select the traffic control signal. Just choose one normally. Here we choose the type of accident with the car. We choose the road. Here we choose no shelter. Here we choose to collide. Then it's all entered. You can also enter the type of accident here. Let's not enter first, we directly calculate the A1 and A2 probabilities. You can see it here, the results predicted by these types. This location may be an A2 car accident. Then the probability of A1 occurring is 16.8%. A2 is 83.2%, so it's A2. Limitations and future outlook. At this time, only severity can be predicted. That is, the situation where the accident has occurred, rather than whether an accident will occur at a certain point. Second, if the input type differs too much from the historical distribution, the confidence level decreases. Limitations and future outlook. We have the following 4 expectations for the future. 1. Data integration. Unify the hotspot map with the forecasting module data source. Ensure consistent coordinates and field standards, reducing duplicate maintenance. Augmented data sources, such as historical incident data, weather APIs, and traffic sensing data. Improve analysis and prediction accuracy. Added automated update mechanisms. Regularly capture the latest incident data from government open data platforms. Next, the hotspot map function has been improved. We can also add an incident density heat map and township road range filter function to the map. Improve analytical nuance. Visualization panels such as accident trend line charts and monthly comparison analysis charts can also be added. You can also add the function of exporting reports to PDF, Excel, or sharing. It is convenient for decision-making units to use. Then, optimize the interface to support mobile responsive design. Next, the prediction module is enhanced. Extend to multi-classification models to predict the probability of different serious incidents. Then, add hotspot analysis to make the prediction results closer to the actual geographical distribution. Introduce deep learning to make time series predictions based on accident risk changes in specific months or time periods. Or connect to the map system through the Flask API, so that the prediction results can be displayed directly on the map. Next, system integration and application promotion. In the future, maps and forecasting modules can be integrated into a single platform. Provide a one-stop analysis page for real-time observation and risk prediction. If you can cooperate with the police unit or the platform of the Transportation Bureau, it can be a practical decision-making aid. Second, establish a mass participation mechanism, such as the public reporting dangerous road sections, to improve data real-time and diversity. Our development platform uses Python 3 with PyCharm. The techniques used are as follows. The data source is the information of the government's public platform. Website architecture. Our website is based on GitHub. The code is in Streamlit. The technique used is Papa-Parse. Here are our references. Okay, that's all for our report. Thank you very much.